Okay, this is the key to the Algebra 1 Unit 8 practice test. We're starting with number 1. You should first, just heads up, if you don't already have these notes down, you didn't get in the class, you can go ahead and pause the video and copy them here. Alright, number 1. Compare the graph f of x is negative 2x squared minus 3 to the graph of the parent function f of x is x squared. Using words, describe at least two differences. Okay, so in most basic terms, this minus 3 right here is going to be shifting the parabola down 3. This negative means that it's going to be opening downwards instead of opening up. And this negative 2 means that there is a vertical stretch of 2, which means that it's skinnier. Okay, number 2. And so if you picked any of these 2, that would be fine. 2 of these, 2 out of the 3. Graph the function f of x is negative x minus 3 squared minus 4, then convert to standard form. Using words, compare it to its parent graph, f of x is x squared. So to graph this, let's get the vertex. Vertex is h comma k, so it's going to be 3 comma negative 4. 3, 1, 2, 3, 1, 2, 3, 4. Okay? It's opening downward, so let's get a couple more points. I got 3. Let's figure out what f of 4 is, because that's right next to 3. So we would get negative 4 minus 3, 1 squared minus 4. So it's negative 1 minus 4, which is negative 5. So we're going to have a curve like this. Okay. So we found the vertex. We plugged in a point next to the vertex, right? The vertex is at 3, so we plugged in a 4. I got since it's symmetrical on both sides, like if it's negative 5 here, it's got to be negative 5 here. So I can draw my sketch from there. How does this compare to this graph? Well, it opens downward, right? That's a difference. It opens down, and it's shifted, right? 3 to the right, and 4 down. Those are the differences. Okay, let's graph this one. So this is in intercept form. We got to convert this to standard form. To convert this to standard form, we are going to FOIL this out, so distribute that out. So x minus 3 squared is, if we did it over here, right, x minus 3, that comes out to x squared minus 3x plus 9. So here would be x squared minus 6x plus 9, all that negative, and then minus the 4. So when we simplify, we distribute that negative through it. We're going to get negative x squared plus 6x minus 9 minus 4, which then becomes negative x squared plus 6x minus 13. And that's your answer. Okay? Graph the function, then convert to standard form using words, compare to factor. Okay, so this one, we have our x-intercepts. X-intercepts are going to be 1 and 3. So I'm going to plot them here, 1 and 3. And then the vertex is in the middle. So the vertex would be has to be at 2. And we can find the value of the vertex by plugging in 2 into the equation. So f of 2 would be 3 times 1 times 1 times negative 1, and that would just be negative 3. So that means your vertex is at 2, negative 3, so 2, 1, 2, 3, and then we can sketch from here. Okay, and then let's convert it to standard form. So to convert to standard form, we're just going to multiply all these together. We'll do x minus 1 times x minus 3. We'll get x squared minus x minus 3x plus 3. So x squared minus 4x plus 3. And then we'll multiply all of that by 3 because we still have that 3 out front. So we'll get 3x squared minus 12x plus 9. This would be standard. And then compare it to the graph x squared. Well, it's been shifted 2 right, 3 down. So you just look at the new vertex, shift right 2, shift down 3, and then it's got this 3 out front, so it's got a vertical stretch of 3, which means skinnier, right? Okay. 4, find the vertex and axis of symmetry of the graph. Okay. So again, all you need to know here is how to read vertex form and understand that it's h comma k, right? So you can, for the practice test, you can look at the notes and see, okay, well, the vertex is just h comma k here. So it's going to be 3, 1. And the axis of symmetry is always just the x value of the vertex. So x equals 3 would be the axis of symmetry. Okay, that's it. Find the vertex and axis of symmetry of this, then convert to vertex form. Okay, so to get it from standard form, it's going to be negative b over 2a. Let's do that. So let's start with the axis. Is going to be negative x equals negative b over 2a. So that would be 6 over 2, which is 3. So x equals 3 is my axis of symmetry. And the vertex will be 3, comma, and then we're going to plug a 3 back into this. So f of 3 would be 9 minus 18 plus 10, which is 1. So my vertex would be 3, comma 1. Okay. Then it says convert to vertex form. You could use this vertex to help you write it in vertex form, or you could use the complete the square method that we learned in class. I'm going to do complete the square method. We have x squared minus 6x plus 10. B equals negative 6. B over 2 squared equals 9. We're going to add and subtract that. We're going to get x squared minus 6x plus 9 minus 9 plus 10. We're going to factor this right here, which is just x minus 3 squared. And then negative 9 plus 10 is 1. And so this makes sense because my vertex is 3, comma 1, and my vertex form is minus 3 plus 1. So you could also have just like got it from here. You didn't have to necessarily complete the square. You could just say, oh, I know the vertex is 3, 1. Therefore, my vertex form must be x minus 3 squared plus 1. Okay, last one. It's factored form. Find the vertex and axis of symmetry of the f of x is x plus 3x minus 1. So it's p plus q. Let's find out what p and q are first. So p is negative 3 and q is 1. My axis of symmetry is going to be p plus q over 2, which is negative 2 over 2, which is negative 1 equals x. And then, again, my vertex is going to be negative 1, comma, f of negative 1. So we'll just plug in negative 1. So we'll get 2 times negative 2 is negative 4. Negative 1, negative 4. Okay? So it's the axis and vertex. Okay, we're on the last page. Consider the graph of the function. Find the domain, range, and zeros of the function. The domain is all real numbers for all the quadratics. It's going to be all real numbers. The range is going from low to high. So my lowest value is negative 4, so it's going to be from negative 4 to infinity. Okay? And then my zeros, where it intersects, are negative 1 and negative 5. It even tells you right here. Negative 1, 0, and negative 5, 0. Okay? Find the axis of symmetry in the vertex. Again, it's all labeled here. the vertex is just -3, -4. The axis of symmetry is just x equals -3. And then write the quadratic function of the parabola in standard form. So I know the zeros, I know the vertex form. It says write the equation in standard form. So we could do this a number of different ways. I could use these zeros right here to write it as x plus 5 x plus 1, right? If my zeros are -1 and -5, that means my factors must be x plus 5 and x plus 1. Then we can multiply these together. x5, x1, so x squared, 5x, x, and 5, so x squared plus 6x plus 5, right? And we know the vertex is -3, 4, so when I plug in a -3, I should get -4. Let's make sure that's true. So f of -3 would be 9 minus 18 plus 5, and that is 14 minus 18, so that is -4, so we're good to go. This is the equation in standard form. So the way I did that is by looking at it, by knowing that the zeros are -1 and -5, I knew that the equation was x plus 5 and x plus 1, and then I multiplied them together to get the standard form, and I just double checked it by plugging in the vertex, the -3, and making sure that I got -4. Okay. You could also use the vertex form similarly. Like you could tell that, oh, if my vertex is -3, 4, that means it's got to be x plus 3 squared minus 4, and then you could do the same thing. You could multiply that out. You'll see here, look, x plus 3, x plus 3, x squared, 3x, 3x, 9. So we'd get x squared plus 6x plus 9 minus 4, which is x squared plus 6x plus 5. And that is the same as what we got from the factored form. Okay, this is factored form. This is the intercept form. And then I just multiplied them out to get the standard form. And you could choose either one of those. Okay. The vertex of a parabola is 4, -3. Another point is 8, 5. Find the third point of the parabola. Justify your answer with words or sketch. So we can sketch this out. 4, -3, that's my vertex, and 8, 5. So this is 4, let's say this is 8, and then 5 up here. So this is my vertex, this is my axis of symmetry, and it's kind of going up like this. So if I know that it's reaching this point over here, remember that it's symmetrical, so I should be reaching the same point on the other side, somewhere over here, okay? So see this distance from 4 to 8, this is 4. So that means if I go 4 to the left, I should also have that same coordinate. This is 8, 5, right? So let's go 4 to left. What's 4 minus 4? It's 0. So that means I should have another point over here that's at 0, 5, because it's symmetrical. Okay? All right, that is the practice test for Unit 8. I'll have office hours at lunch if you need me. See you soon.